I'm here to introduce to you SAM, the toolkit that we've built out of the Royal College of Art and Imperial College London. I'm a mechanical engineer, and I was fascinated by how complicated we always made simple things sound, and why that was creating a divide between creative people, like my friends at the Royal College of Art, and people like myself, engineers who were often more interested in optimizing pre-existing systems rather than applying existing working models to new fields and new systems for step changes. We've decided to work on SAM as the field of the Internet of Things is nearing. Well, it's not nearing, it's actually been there for a while. It's just the idea that objects will be connected to each other. The new thing about it is it gives us an opportunity to include many more people in the debate of new product creation. Why? Because we've seen a recent heavy decrease in the cost of rapid prototyping for any kind of product, and also an increase in the information available for people to create these new devices on the internet, but also in terms of manufacturing resources, crowdfunding campaign like Kickstarter. And as a bit of a background, it's estimated by, well, a few people now that by 2020, so less than 5 years from now, there'll be about 80 billion devices connected to the internet. It means that we'll have approximately more connected devices than we'll have friends around us. So we've decided to create this toolkit. This toolkit is here, and I'm happy to give you an individual demo after the presentation, but we have taken out the components out of electronics. I'm a mechanical engineer, and I was always afraid of mechatronics, the field of what was then electronics. And the biggest task in the labs was to find the most brilliant colleague in the classroom and make sure that I would stick with him for the rest of the workshop. We decided to simplify, and it was true for me as it was true for most of the students around there. So we're lucky that 1 out of 10 students understood what was meant by electronics, and we'll make sure that we would be with them. So what we've decided to do is we've decided to divide up electronics to core components and strip away everything that was complicated around them. What is complicated around electronics is this idea of having to wire everything correctly before anything works. This idea that we can't really debug anything when we first start playing. And also, when you start to make interactive systems, the idea that you must actually code to get anything working. And so we've created SAM. SAM is the Lego for the iPad generation. Why the word Lego? Because it's playful. Anything that you start enjoying at a young age, and also at an older age, that becomes something serious, needs to be enjoyable first. It needs to be, well, like Lego. Similar to Lego, it's also modular. You can get these pieces that I'll show you in a second into simple circuits like electronic doorbells and smart fridges, but also in remote control cars or wonderful little movable wearable tech. And I thought I would give you a little demo. So I'm changing to my other computer now. Let's see. Oh, there you go. If you don't mind, I'll just... There you go. Excellent. So in SAM, we've got two things. We've got these modular building blocks, and they talk directly to an app, an on-screen experience that can go both on computers, laptops, tablets, and mobile devices. What happens with SAM is that you get these bite-sized electronic building blocks. This is a button, and as soon as I turn this button on, you can actually see it at the top left of my interface, it being turned on as well. So this is red over here to just say that it's on, but not yet paired. And it's appearing there on the top left of my interface. To connect to this button, the only thing I need to do is pair with it on my interface, and then drag and drop it in the middle of what we call the canvas. it's now turned yellow, like the little ball, just a little circle just in front of it. And now every time I press on this button, you can actually see on the interface that it's being pressed. You get this idea of immediate feedback with these electronic devices. Again, I managed to see the two states of a button visually on an interface without having to code anything and in the space of 5 seconds. Say I want to create a control for a light. Just turning a light on or off, which is usually the first exercise you do in electronics. What I would need to do is just turn on my SAM, see it appear on the top left of my interface, pair with my SAM, and to connect my button that's on the table to this little light. I'll position it here and we'll hope it won't fall. I was always told never to do live demos, but it's just too much fun. So what I need to do just to control this light with this button is on my interface, connect the dots. Again, no wiring, no close proximity, and now they're actually connected. So if I were to press on this button, the light turns on at 30 meters distance using a technology called Bluetooth Low Energy. If I want to change the parameters of this light, so we've established a connection and also direct feedback. So you actually see that this actually turns on and it tells me the state of my light. If I want to change the parameters of this light, say what colors it should turn to, I can simply access that light as if it was just a person or a simple object that I can change and model at will. So now I've chosen the color blue. And now if I press, the light will turn a different color. If I want to add the idea of functions of behavior, we mentioned coding 2 seconds ago. Well, what is coding between objects? It's essentially behaviors, and we've done a lot of work around language, making it understandable for children and also adults to understand what goes on between these devices. Say I want to explore different colors at every button press. Here's a behavior called RGB, and if I drop it between my button and my light, the light will change color every time I press. If we were to add other devices, so now we'll start going a bit quicker. If I want to add any number of devices, I simply turn them on and I can create, well, systems, ecosystems we call them, of devices that behave in their own way. So here my button is now connected to 2 different lights, and if I press, both of them will turn on, but each of them has got their own particular behavior. I've now got a dimmer. A dimmer is often used in our room to dim the light. So I'll just decide that the dimmer will control one of the lights. And you'll notice this idea of constant feedback. So here, if I twist this dial between my hand, I can actually see the different states. And although it sounds a bit trivial, it makes a big difference in being able to understand both digitally and physically what's happening. And here, I'm just connecting to my light. And now, again, without any coding, we're starting to take this for granted, which is the very, very good thing about SAM. Is after a while, you just think that, of course, things should be connected together very, very simply and wirelessly. So here's my dial, and if I turn it, you'll see the value. I've actually not been looking, so I hope they've been working all along. They should be. There you go. It actually turns on and off. And you can start, again, adding these devices. I've got a vibration motor here to give me haptic feedback. I've got a DC motor over here to turn around. I've got a light sensor over here as well to tell me how bright it is in this room. So let's start creating something. I want to be told whenever it becomes bright somewhere, I want my vibration motor to turn on. So here I'll just drag and drop my vibration motor on the interface, and I'll drag my light sensor as well. My light sensor, as you may guess, tells me how bright it is in this room. So here, if I cast a shadow on it with my hand, you will actually see that it's a value of 0. If I go close to the window, it should give you a value close to 100. Now I want to connect my light sensor to my vibration motor. Make sure that I get notified whenever the day breaks. Well, here it's connected, and for lack of a better display, I'll just put it at the center. Here. It's now starting to move. Just because I've let a bit of light go onto it, and I get direct feedback and can establish these connections very, very easily. Thank you.
This is terrific.
But say you want to create a smart system. Say you want to get this idea of energy conservation. Well, I mean, but the idea of avoiding wasting energy. Having the idea that whenever you're reading, you want the perfect amount of lighting, but when it's bright outside, you shouldn't get the lights on in your room. Well, for that, you might think, I should connect a light sensor to a light. And here you see that whenever it gets dark somewhere, well, the light they're quite sturdy, so it should be fine. Whenever I hold it in my hand, it gets completely dark, but whenever I cast a bit of light onto it, it should brighten up. That's not exactly what we want. We want the opposite. We want an inverse relationship. The same way I use the RGB relationship, I can just take it here in my behavior, and now include it between the light sensor and the light. So now, whenever it will be dark, the light will be bright, and vice versa. So whenever my hand is on top, it's now showing a lot of brightness, and whenever I get close to the window, it should dim down. And then we started thinking, but what if people want to go further? I mean, it's all good and well to have these relationships like filter values, allowing me to go between different values if I want my dial to just be between 30 or 70 or any other number, or if I want to add the idea of logging values to make sure that I can carry out scientific experiments in a really easy manner with temperature or pressure. What if we want to add the idea of being able to code yourself? And this is why we've decided to have this idea of going from simplicity to complexity in the easiest manner possible. You start off very, very easily by connecting these devices, getting feedback, and getting used to these actually relatively difficult concept of, well, data flow, feedback, and electronic connections. And then you start working through behaviors to finally go into, well, coding. This code module is a basic JavaScript interface. It's a little JavaScript IDE that allows you to connect to these devices, and it declares the input immediately as you connect it. So here it's connected to a light sensor, and at the output it's a vibration module. And on the right, it's explaining to me which values both accept. The vibration module accepts a value between 0 and 100, and so does the light sensor. I can start coding within that interface. And then we decided to go further. How about adding something that people, I don't want to say that they don't care about engineering, but most people care about, well, so the social aspects of things. How about adding, well, something like Twitter? Why shouldn't we allow people who create new devices to connect to the social media? So here, if I want to say hello from the Royal Society, and I will just put our handle here as well. I can get this little camera, hello. And what I can do is, if you don't mind, you all look fabulous today, so it will be fine to do that. I've connected this button to the camera on my computer, to the Twitter API. And so if I'm to click, there you go, if I'm to click this little button, it has taken a picture and posted it onto the internet. So let's look for proof. So here on the internet, we have just posted that picture in a matter of seconds. So it's always good to remind ourselves about how long these things would usually take. Here we are on the internet after a setup of about 2 seconds of bringing these difficult components together in actually simple terms in an interface, in something we all understand. And then there's also the opposite, which is quite interesting to see what popular subjects are going on Twitter at the moment. It's Twitter in. How do we get data on the internet as a sensory, not a sensory device, but as a sensor value? And I'll explain that to you in a second. So here we've got Twitter in, we've got the little RGB module, and here I'm going to track how many people talk about the US today. Every time someone mentions the US, my light should turn a different color. And here you go. This is someone somewhere in the world talking about something on Twitter, #USA. And you can start, I mean, the most fun is translate for me, I don't know why, I've got this weird fascination about translating the internet into physical output. So here's the vibration module, and it's even, to me, more powerful than a light to actually see something move every time someone mentions something. It gives you a whole idea about how you can do, remote communication on a completely different level. So this is how the SAM app works, and we've done quite lovely thing to it for the year and a half that we've been active. David, I might need your password just to get back into your computer. Don't shout it. That's fine. So, and here we introduce a few concepts that we managed to do with SAM. So this is the ability to send a message on Twitter, like I've shown you, and these were all created by people outside of SAM. These were workshops that we've done with school children, art students, and also architects. This was just the ability to see whenever you've been posted something on Twitter with physical feedback. This was an artist and a kid creating an installation around a Batmobile that they had in mind, being able to catch villains in the dark with a remote control car. This was an idea for a cat feeder. Now you'll notice that the cat is not real, and I'm not sure that almonds are the best diet for cats. But nevertheless, this was created by a 10-year-old who had this idea, and he was really, really frightened that his cat wouldn't get fed if his parents left on a weekend. This was a sensible robot, a robot that was looking at you in a different way depending on where you were putting your hand. Created with the same modules. We had a 4 servo motors and 2 proximity sensors attached to the robot. It would look at you angrily to the left and happily and with a curious look on the right. This was super nice. This was a fashion designer who had never dabbled with engineering electronics before, creating a skirt that would move around to the sound and rhythm of music. Now, what's really important for me to understand is that these are the people to which technology could add a tremendous amount of value, but are usually too scared, like I was as a mechanical engineer, to come far or close to it. Making things easier allows to get many more people in the debate. And that was his colleague who found another way to express himself with technology, creating a twerk bot to make sure everyone in his classroom, or the relevant people, knew how to twerk. This was a workshop done with parents around children and the way they wake up, creating an interactive interface to make sure that we'd have a competition around waking up, and we'd have a trackboard to see who would wake up the fastest. And this was another more emotional use of technology, the ability to communicate with your partner through hugging an object that they had given you with a simple pressure sensor connected to the SAM app and their account on their phone. And this was an interactive doorbell, being able to create a doorbell that would take a picture of you if you're in front of the door and send it over to someone else's phone. That was the granddaughter of someone who had trouble taking the right pills at the right time, a problem called medical compliance. Again, a graphic design student who was the first time interacting with technology, and she created a medical compliance box that could measure which pills were put on what days, and also which pills were taken away from that box on what days. So being able to say, yes, these are the right pills, like the ones you've got in the supermarket, these are the right pills you're putting in these boxes, and being able to communicate with the family or the doctor if the treatment was going according to plan based on what pills were taken. There's, in the concept of the Internet of Things, and these 80 billion devices connected to the Internet, there will be a whole array of issues that most likely governments will take a while to take their positions on, and that will, in our opinion, need a strong, consumer leadership. We will need to come up with these solutions or our ideas, our stance on these issues before we can actually have general agreement on them. And we believe that the more people cast these ideas, not just engineers and technocrats, but actually creatives, children, designers, architects, people who usually don't have the tools or the knowledge to do so, the fairest society and the fairest market we'll have for the Internet of Things. We would like get to not be driven by the biggest companies, but maybe by the most enlightened minds. And this is why we've created SAM, our little wireless toolkit of electronics. Now, I'm inviting you to follow us and keep up with our adventures. We've been going for a year and a half now. We're a team from London, a really strong London team from Imperial College, Royal College of Art, and LSE, as represented by David over here. And this is where you can find us, and of course, we'll be sticking around and we'll be happy to give you a demo. Thank you very much.
Thank you, Joachim, for that presentation. I could actually hear gasps of inspiration in the room, so that was really great. There's time for one or two quick questions, otherwise you can catch them afterwards. Has anybody got a question?
Is this a company now, and are you public or are you still private, and are you looking for investment?
So we are a company, Sam Labs, based around Old Street. We are on the brink of closing our investment round, and we've done a first go-to-market exercise last year that was well received, and we're now selling these on our website and a few shops.
Great.
Make sure we talk to you afterwards.
Does each sensor, obviously I'm pretty sure I know this already, each sensor does not have its own microprocessor.
Of course, each sensor does.
It does?
It does. So it's interesting technology. I'd love to talk to you about it afterwards. Each sensor's got its own Bluetooth antenna, microprocessor, and recharging circuit. Each sensor is its own mini computer. And they could run with or without the computer as well.
About power, how
Yeah, so one of the main issues with the Internet of Things is the ability to keep, power for a long time. Our button lasts 3 months. You've got different states that you can put it in, so make sure that it's all on lowest energy usage possible. It ranges from 3 months to the servo motor that's got a slow battery and quite a lot of current that it draws that lasts about 40 minutes, but that's just a tiny motor. You can plug these onto legacy hardware pieces to make sure that they last for long.
You're putting solar power on those, power not on those.
So there are interesting technologies to recharge the modules. We've tried a few of these. Solar is not there yet, but we'd love that. I mean, of course, it's the best option.
Same thing with the light sensor.
Yeah, absolutely.